Hi. In the previous video, we discussed the benefits and drawbacks of using compiled code. In this video, we're going to narrow our focus to the Python standard library's ctypes package, which allows us to interact with dynamic libraries from within Python. Probably the most common need to interact with compiled code is when there's a library out there that does exactly what we need. But it's not a Python library. Instead, it was written for C, or at least has a C interface. We're not going to let a little thing like that stop us. Instead, we'll use ctypes to create an interface module for the library. For basic usage, ctypes is very simple. We import it, load the dynamic library by file name, and call a function in that library. The cdll constructor we're calling here creates a Python object representing a dynamic library containing C functions. There's a little complexity in picking the library file name. Because different operating systems have different naming conventions for libraries, libc.so.6 is the file name of the C standard library on current versions of Linux. ctypes includes a utility function to help address this difficulty, called ctypes.util.findLibrary. If we pass a base name into findLibrary, it will try to find the full name of the version installed on the system. That's pretty useful on Linux and Mac OS X, but less so on Windows, because Windows dynamic libraries handle multiple versions in a very different way. It's also worth noting that while passing the string C into findLibrary, we'll find the C standard library on Linux and Mac OS X. On Windows, the same library is rather arbitrarily called MSVCRT. For cross-platform library loading, we need to be able to specify several alternate names for the library. Try findLibrary on those names, and fall back to trying the raw name if findLibrary fails. There's a load library function in the demo underbar ctypes/lib.c.py file included with this course video that demonstrates this. Once we have the library loaded, we have access to the functions exported from that library, which are exposed as attributes of the library object in Python. We saw that earlier when we called C's printf function. Now it's important to know that there's nothing in a C-shaped shared library that tells users of the library what the parameter types of a function are, or the return type, or even how many parameters the function has. That information is used when compiling the library, but it's not part of the end result. That means it's up to us to know how the function is supposed to be used. For example, the C library contains a quick sort function called qsort, which is intended to accept several parameters. As you can see here, if we omit those parameters, ctypes has no way to know we're making a mistake and bad things happen with no warning. If we're planning on making systematic use of a foreign function, or especially if we're going to expose it as part of the interface of a module we're writing, we're well advised to tell ctypes about the function's signature, which we can do by assigning to the function's argtypes and rest-type attributes. The argtypes attribute should be a list of C data types defined in the ctypes package, while rest-type should be a single one of them. As you can see, providing this information to ctypes significantly improves the error handling for a foreign function. The @of function returns a double precision floating point number, but ctypes wouldn't have any way know that if we hadn't told it. When it doesn't know better, it just assumes the return value is an integer, which works in many cases, but would have been useless here. It's pretty common for C functions to accept a pointer as one of their parameters, and fill in a value at the address the pointer refers to. Naturally, ctypes allows us to work with that sort of interface by letting us create objects that represent memory locations and pass them by pointer to the functions we call. The cscanf function works like this. Here, we're creating two C-style variables called integer and decimal, and then using the scanf function to fill them with values based on user input. The byref function tells ctypes that we're not passing the value of the variable to the function. We're passing its memory address, so the function can store something there. Another common behavior of the C functions is for them to fill bytes into a character buffer. We can use the ctypes createStringBuffer function to allocate such a buffer, and then use the result as a parameter for functions that want one. There's no need to use the byref function because the character buffer is inherently by reference. There's just no other way to do it in C. There's a pitfall here, one that's been tripping up C programmers for decades. Our string buffer has a specific length, but the function we're passing it doesn't know what that length is. If it starts writing into the buffer and goes on beyond the end of it, the program will either crash or begin behaving strangely. Always make sure your buffer is at least large enough for whatever will be written into it. Another thing that is not available from looking at a C shared library is the layout of any data structures that the functions use. Again, ctypes gives us a way of filling in the missing information. The ctm structure, which is used for representing date and time information, looks like this. The translation into ctypes is straightforward. We need to create a class inheriting from ctypes.structure, and in that class, we need to create a list called fields, containing tuples of field name and field type. Once we've got that, we could create instances of the class and assign the attributes as we'd expect in Python. But we can also pass it into C functions as a parameter, either directly or by reference. And we can use it as part of the signature of a foreign function. The ctypes package provides support for pretty much every feature of the C language. But we've now seen the ones that are most useful for calling into a library function and using its results. In this video, we've seen how to use the ctypes package to tie into the interface of a C dynamic library, calling the functions and receiving their output from within our Python code. In the next video, we'll see an easy, as such things go, way to write compiled code modules so that they could be imported and called directly from Python.